Welcome to AP Statistics. Today we are diving into topic 2.1, where we explore how to represent and analyze the relationship between two categorical variables. Our learning objectives are, first, compare tabular and graphical representations for two categorical variables, and second, justify claims using these representations. By the end of this lesson, you will be able to interpret two-way tables and various types of bar charts to determine if an association exists between variables. Let's focus on the relationship between two categorical variables. When we look at just one variable, like favorite color, we are looking at a univariate distribution. But in the real world, we often want to know if one variable, like grade level, relates to another, like preferred sport. This is where bivariate categorical data comes in. To start our analysis, we use the most fundamental tool for bivariate data, the two-way table. A two-way table, also known as a contingency table, organizes data by two categorical variables. One variable forms the rows, and the other forms the columns. In this example, we are looking at grade level and music preference. Each cell in the middle represents a count, or frequency, of individuals who fit both categories. For instance, there are 50 students who are both in 9th grade and prefer pop music. While these are raw counts, we often convert them into relative frequencies, or proportions, by dividing each count by the total. This makes it much easier to compare groups of different sizes. You can now identify a two-way table as a way to summarize two categorical variables. Tables are great for details, but graphs help us see patterns instantly. Let's look at 3 ways to graph this same data. First is the side-by-side bar chart. Here, we group bars together for each category. This allows us to compare the frequencies of music preference directly within each grade level. Notice how the heights show the raw counts we saw in our table. Next is the segmented bar chart. Instead of putting bars side by side, we stack them into a single bar that represents 100% of that category. Because both bars are the same height, 100%, we can easily see the proportion of each music choice. Even if the number of 9th and 10th graders were different, these percentages allow for a fair comparison. Finally, we have the mosaic plot. This is a special type of segmented bar chart. In a mosaic plot, the width of the bars represents the sample size of that group. The wider bar for 10th grade tells us there were more 10th graders in our study. You can now distinguish between side-by-side, segmented, and mosaic plots. The main goal of using these graphs is to determine if there is an association between the two variables. Knowing the value of one variable helps predict the value of the other. If the distribution of the categorical variable is the same across all levels of the other variable, we say there is no association. Notice how the segments align perfectly. Knowing which group someone is in does not change our guess about their preference. However, when the segments are different heights, as we see here, an association exists. If you are in Group A, you are much more likely to be in the blue category. Take a moment. If the bars were exactly the same, would the variables be associated? The answer is no. If they are the same, the variables are independent. You can now use graphical representations to determine if two variables are associated. Let's apply everything we have learned to a real-world scenario to justify a claim. Suppose a researcher claims that participation in after-school activities is associated with a student's sense of school belonging. We collect data from 200 students and create a segmented bar chart. On the x-axis, we have students who are involved and those who are not involved. The y-axis shows the percentage reporting a sense of belonging. To justify the claim, we look at the differences in the conditional relative frequencies. We can justify the claim by stating, yes, there is an association. Students involved in activities are nearly twice as likely to report a high sense of belonging, 75%, compared to those not involved, who only report a high sense of belonging at a rate of 40%. When justifying a claim on the AP exam, always use specific values from the table or graph and use comparative language like greater than or different from. You can now justify a claim using data from a graphical representation. To wrap up our lesson on topic 2.1, let's review our main objectives and the key tools we've added to our statistical toolkit. First, we learned that a two-way table, or contingency table, is our primary method for summarizing counts or proportions for two categorical variables at once. Second, we explored 3 visual tools: side-by-side bar charts to compare counts, segmented bar charts to compare proportions, and mosaic plots to compare proportions and group size. The side-by-side chart is best for looking at raw frequencies, while the segmented and mosaic plots are superior for comparing the distribution of one variable across levels of another. Remember, the presence of an association means that knowing which group an individual belongs to gives you information about their likely outcome in the other variable. When you are asked to justify a claim, don't just say the bars look different. Use the numbers. Citing the specific relative frequencies is the key to a high-scoring response. You are now prepared to analyze the relationships between categorical variables using both tables and graphs. Great work today!